Hello everybody. We're working through some matrices today, but before we get to do that, your bell ringer here is a system of 3 equations. So please work through that. Please pause the video while students work through this and give them about 5 to 10 minutes, and then start the video and check some answers. Okay, so we can solve this with any method. The preferred method here is probably elimination, and if we look at the z's, that's probably the way to go, because we have easier numbers in the z's and we have some opposites going on. All right, so starting out, let's look at equation 1 and 2, and we want to eliminate the z's. So we're going to take this second equation here times a 2, because they're already opposite, and we're going to write them off to the side. So taking the second equation by 2, we'll have a 4x plus 2y minus 2z equals 10. And then we can eliminate those two equations. You see the z's cancel out. So we got 9x plus 5y equals 12. Okay, so we're going to use that equation. We'll come back to it. So for the second round of elimination, we're going to use equation 1 and 3. Okay, so equation 1 and 3, we just need to take one of them times a -1. So we're going to do the same thing we did over there. Let's write them out and multiply the second equation by a -1. So we have a -x minus 4y minus 2z is equal to -16. Okay, so then we add those down. Again, the z's cancel. We eliminated the z. So 5 minus 1 is a 4x, and then 3 minus 4 is a -1y. Z's are gone, and then we have a -14 over there. So here is our second equation. So now we have to eliminate between these two equations. And I would probably go with the y's, just because it's a -1 over here. So let's take this equation, multiply it by a 5, and that will eliminate the y's. So we'll write that over here. So 5 times 4 is 20x minus 5y is equal to, so 5 times 14 is a 70, so -70, and we're just going to add those two equations together. All right, so we have 9 and 20, that's 29x. 5 and -5, the y's are gone, which is what we wanted. And then we have a -58 over here when we add those together. So divide both sides by 29, and we get a nice number. We get a -2. So that is our x. So now let's take that, plug it into this equation. We could do this one as well, but the one on the left here is a little bit nicer. So plug it in for the x. So 4 times -2 minus y equals -14. So this is a -8. So -8 minus y. So we'll add that 8 to the other side to move it away from the y. And then we get -y is equal to -6. Multiplied by a negative, and we get y equals 6. All right, so now we got two answers. To get the third answer, we plug it into one of our original equations, and I would probably go with this one just because there's less numbers to use. So plugging our x in, so we'll have 2 times -2, plug in the y in, you get a 6. There is no z yet, that's what we're solving for, and set it equal to 5. So go from there. That's a -4. So -4 plus 6 is a 2. So we now have 2 minus z equals 5. Minus 2 on both sides. And then we get a 3 over there. So then we get z equals -3. So that one worked out fairly nice. So we have an ordered triple of, I'll write it up at the top, -2, 6, and -3. So for the lesson today, we're going to be going through our first day of matrices. We're just going to do basic operations. It'll be addition and subtraction and scalar multiplication. So it shouldn't be too bad. So follow along on your note sheet and we'll get through this. So again, we're going to be doing matrix addition, subtraction, and scalar multiplication, and then we'll follow up the next class period and work with multiplication of matrices. So first of all, we got to kind of identify what a matrix is. Okay, so we're performing basic matrix operations. Introduction to matrices right here. Okay, matrices is plural of matrix. All right, so a matrix is just a rectangular array of numbers. There's actually a movie called The Matrix. Hopefully some of you guys have seen it, but it's just a whole bunch of numbers. Like at the beginning of the movie, it's a bunch of green numbers going up and down on the screen. Those can be an example of a matrix, okay? So I have an example of a matrix right here. This is just a basic matrix here. And we're going to go over the way we read the size of a matrix, okay? Because it's not just, it's a 6-number matrix. We got to read the size, okay? So the way we read the size is we first look at the number of rows, okay? And we can say that this is row 1, row 2, row 3. So we got 3 rows, all right? And then after that, we look at columns, okay? So this would be column 1, column 2. So we have a 3 by 2 matrix. Okay, when we're looking at the size, we don't really care about the numbers that are on the inside. We just care about how many rows we have and then how many columns we have. Okay, so this would be a 3 by 2 matrix. When you guys start to work in your graphing calculators with matrices, which we may or may not do in here, you have to know the size. If you don't have the size correct, then it's not going to work in your calculator. Okay, so looking at that, you need to have this written down in your notes somewhere, okay? You read it as rows by columns, okay? And it doesn't matter, like I said, it doesn't matter the numbers in here. You can just slap 6 numbers in a matrix like that, but you have to make sure there are 3 rows and 2 columns. When I read the size as rows by columns, that will be beneficial for when we get to multiplication at the second half of this lesson, okay? So, before we start adding and subtracting matrices, okay, I want you guys to look at these 2 matrices here and tell the other people at your table what the sizes of each of them are. Okay, go. Hopefully you said they were both 2 by 2, okay, because we have 2 rows and we have 2 columns. So it's just a 2 by 2, all right? Another special word for something that it's like a 2 by 2 or a 3 by 3 or a 4 by 4, which we probably won't get that big. 4 by 4. These are called square matrices. Okay, so you think of a square, it's going to have the same side lengths all the way around. Okay, so it could be a 2 on one side and 2 on another side. So it's going to be the same side lengths all the way around. Same thing with matrices. You're going to have the same number of rows as you do columns. Okay, those are called square matrices. Right? So good information. Looking at these 2 matrices, hopefully you looked at the worksheet that I gave you guys on Friday. I told you to look at it quick before you left. It's not too difficult to add and subtract matrices, okay? First thing we have to look at is if the sizes match, okay? So with this one, we already said they're both 2 by 2s. The sizes match, so we are good. Then you can add them, all right? And addition and subtraction works the same way. Addition, you just add the corresponding pieces. So I'd add this 3 with that -1. And when I make my new matrix, it'll go in that same slot, okay? 3 plus a -1 is 2, all right? And then we look at the next one, all right? So let's move these guys over here. Let's look at the 0 and the 4. 0 plus 4 is just 4. It goes in that corresponding slot. Next one, a -5 with a 2. -5 plus 2 is a -3. And then the last one, -1 plus 0 is -1. So we have a new 2 by 2 matrix after we added them together. Okay? And subtraction is just as crazy. All we got to do is subtract the same corresponding pieces. Okay? This operation here is kind of where I like to do the add a line, change a sign thing. I never really did that with my addition and subtraction, but it kind of is nice here because there are so many numbers over here. So rather than thinking of it 6 different times, you can kind of change everything once. So what I want to do is change that negative. I want to distribute that negative. I want to give a negative to everything in here and then turn it into addition, okay? So it will look like this. So add a line, change your signs. And I guess the 0, you don't need a negative in front of the 0. All right, so that changes positive, positive, negative. Now you're pretty much adding a negative, which is the same as subtraction, okay? That's the easiest way to do matrix subtraction rather than thinking about it 6 different times. So now we got 5 and a positive 4, okay? 9. See if you can finish the rest of that real quick. See if you can get it done before me. So 3 plus a negative 2. 1. Negative 1 plus 0. Negative 1. And then I have a negative 2 plus a 3. That's a positive 1. 4 plus 1. That's 5. 0 plus a negative 6. That's negative 6. So pretty crazy, right? Addition, subtraction, it's just as easy as addition, subtraction, just doing it more than once for each matrix, okay? And you can have a 1-by-1 matrix. It just doesn't happen very often in math because it's a pretty simple, it kind of defeats the purpose of doing matrix operations, okay? So addition, subtraction. The next thing, just as crazy as addition, subtraction. Once you get to fractions like that 1/2, it's not bad, but people don't like fractions. We all know that already. Okay, so it's multiplying by a scalar. I've used that word in class before with the equations. Okay, when you scale an equation, you use a scalar. You just multiply that number all the way through. Okay, all the way through the equation. We do the same thing with a scalar in a matrix. Okay, so it's kind of like distributive property. I'm going to take this negative 2. And I'm going to multiply everything in my matrix times a negative 2, which will give me a new matrix. Okay? So negative 2 times a 3. Oops, back up here. Negative 2 times a 3. That is a negative 6. Negative 2 times a 5. Negative 10. Negative 2 times a 6. Negative 12. And negative 2 times a 10 is a negative 20. So that's your new matrix. Okay? If you haven't written this second one down, go ahead and do it, and then see if you can multiply that 1/2 through there real quick. Okay? Now, the one thing you might be thinking here is, can I have fractions in matrices? Yes, you can. You can have whatever number in the slot there is. Okay? Because this is like a, and I forgot to call these before, these are elements. Okay? So that 6 would be an element of this 3x2 matrix. You can have a fraction in there, you can have a decimal in there, you can have a variable in there, it doesn't matter. Okay, but right now we're just working with numbers. So we take the 1/2 and multiply it into each piece. Okay, and 1/2 is pretty simple. You just cut the number in half or put a 2 underneath it, and that's a negative, so it'll change our sign. So the first one will be a negative 3, then be a negative 5, be a negative 2, negative 4, and then here, once we get to that one, it'll be a negative 3/2. Because 3 doesn't cut evenly, and then a negative 7 for that 14. Okay, put our brackets there, and that's our new matrix. Okay, not too bad. So hopefully, all the stuff that I've gone through so far has been on that worksheet that you looked at last Friday, if you did. All right, so I want you to look at these 3 problems here, and I want you to try them, okay? You don't have to write them down as you see them. You can kind of just do them on your notes. Just kind of, you can add them in your head and write down your solution. When you write down your solution, I want you to check with the people at your table to see if they are correct, okay? Go ahead. And pause the video if you need to. Okay, on the first one, remember on all of these really, the first thing I said, in order to add and subtract matrices, you have to have the same size. So you need to look at the size of each of the matrices. First one is a 2x3. Second one is a 2x3. We're good there. Okay, for the second problem here, look at these 2 matrices. They don't look the same. They're not oriented the same. Okay, so remember size is rows by columns again. So this is a 2 by 3. This one is a 3 by 2. So the sizes don't match. They're backwards, okay? So this one, no solution. You can't do it. So sorry if you wasted time trying to do that one. You can't do that one because they don't match. But the other two, the top and the bottom one, you can do it. So let's do them real quick if you haven't already. So this new matrix it's going to give me, remember, add the corresponding pieces. Okay, so that'd be a -8, and then a 4, -9. That's going to be the right-hand side. It'd be a 15, 6, and then a 7. That's our new matrix for that addition problem. Okay, let's look at the bottom one here. So we are subtracting. Remember the best way to subtract. Add a line, change a sign. Boom, 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 boom. Flip all your signs for that matrix and change it to an addition problem. Much easier to add than it is to subtract, especially when negatives are involved. So then we're going to have a 3, -4, 8, and then a -13. And voila, you're done. Okay? Addition, subtraction, pretty quick. Okay? If you ever need to rewind in the video, please ask the sub, and he or she can do that for you. Okay? So jumping ahead, I want you to try, just do the bottom one here. Do that one real quick. All right, and I said real quick because it should be pretty quick. It's only a 2 by 2 matrix, multiplying everything by 1/2. Okay, which gives us this new one of a 1. Remember, it's 1/2 times each of these. So it's a 1, a 2, a 3, a 4. That's what it works out to be with the scalar multiplication. All right? All right, this one, you got to make sure you write this one down. There is a couple problems like this on your homework, and you kind of got to follow along on how to do it. This is the more complicated side to addition, and we'll have some of these with multiplication as well. All right, it looks terrible. It's not bad. So please write this down, and then we will go. If you need time, pause it, please, and then we'll jump into the example. Okay, so we have to solve for variables in matrices now. Like I said before, you can have matrices or variables in these things, which we do here. We have an x in this one, and then we have a y in that one. Okay? And you kind of got to think of how these are going to work out if you just tried to do what the operations are telling you to. Okay? Because that's a scalar there. That's an addition problem there. And then you're saying that it's going to equal this stuff over here on the right. Okay, this stuff. So let's kind of look at the piece that we need. So let's look at the x here. Can we make a little equation using the operations that we have here to see if we can figure out x? Probably. Think about how we add matrices. Well, if I took this matrix here, okay, if I took that one and I added it with that one, then this is what I would have. I would have 5x plus 3 because we had those corresponding areas, right? Okay, so if I did the 5x plus 3, then the next step that would come would be that scalar multiplication out in front. So now it's kind of starting to come together. Hopefully you can kind of see what number I'm going to set it equal to, because where have I stayed consistent in these two matrices? I have this 5x, I have that 3, so then more than likely I'm going to be using that -21. And then this stuff right here, that's easy enough that you can solve that. All right, so go ahead and solve for x. Okay, so to solve for x, you distribute that 3 in there. Boom, boom. 15x plus 9 equals -21. Move the 9 over. Then we have 15x equals a -30. And guess what? X equals a -2 because we divide both sides by 15. Okay? Pretty simple. It just looks pretty crazy. So see if you can set it up for y and solve for y. All right, so see if you can get that y. Tell the people at your table what the y value is, and pause the video so they have time to do that. All right, back here, let's set up our equation. We got that 3 out front, scalar multiplication, -4 plus a -y. I'll just write it as it is there. and I can fix it here in a minute, equals negative 24, because we're going to use these corresponding pieces, right? The bottom right-hand corner. So let's distribute, boom, boom, negative 12, and it's minus 3y equals negative 24. Add 12, negative 3y equals a negative 12. Divide by negative 3, and then you're going to get y equals a 4. And guess what you can do with these numbers that you have? We have an x equals something, and we have a y equals something. You can plug them in to check and see if it works. Okay? So if I put that negative 2 up in here where that 5x is, that would change that to a negative 10. If I do negative 10 plus a 3, that would give me a negative 7 times that scalar. Negative 7 times 3 is, boom, 21. That's how we check it out if we want to see that, okay? Those are the more complicated ones for addition, all right? Hopefully you got that.
You set up two equations wherever those variables are. Okay?
So for your homework today, it's going to be a little bit different format. It's not going to be in your textbook because our textbook doesn't have matrices in it or matrix operations. So we're going to be using an old pictures of an old textbooks that I had. So you need to go to Google Classroom, and the assignment should have uploaded while you were in class, while you were watching the video. So I'll show you where that would look like, or what that would look like. So in Google Classroom, it'll be the Matrix Day 1 files, addition and subtraction. It should show up on the stream, but there's an image file of a previous textbook, which you should be able to use that to work through your questions, okay? I'm hoping it turns out okay on your Chromebooks, but that's where we're going to do our homework. So let me know if you have any questions on the homework. And like I said, the numbers are with that, so there are your numbers on that assignment, and that will be due the next time we have class. So thank you for watching, and have a great day.